This call is being recorded. And now to begin the program, I'd like to introduce Tracy Cook.
Hello, everyone, and welcome to today's webcast, Lessons Learned Deploying Microsoft Private Cloud at Scale, presented by Virtualization Review and sponsored by Rackspace. I'm Tracy Cook, and I'm so pleased everybody could join us today. Before we begin, I'd like to cover some housekeeping details. We'll have a Q&A session at the end of the webcast. Please feel free to submit your questions into the Ask a Question box on the left side of your console at any time during the live event. We'll get to as many of your questions as we can. And finally, this event will be archived and available for replay. You'll receive an email within the next 48 hours informing you when the replay is available. And now I'd like to present our speaker, Kent Kingery, Senior Manager of Product and Engineering at Rackspace. He has more than 30 years of systems delivery and integration experience, from systems integrators like IBM and Accenture to industry positions with companies such as Capital Group and iHeartMedia. He has worked across the entire systems lifecycle and has the scars to prove it. So with that, I'm happy to welcome Kent Kingery. So Kent, please take it away.
Thanks, Tracy. Thanks to everyone for joining us. That really is how I look in real life as well. I actually am a cartoon character. I do want us this to be as informational as possible. Hopefully it'll be entertaining as we go. I've sat through enough webinars where things can get a little dry and boring. We'll try to keep it from being that. I do want to talk real quick about the goal of this webinar. We want to talk about lessons learned, but the idea is for us to paint a picture of the private cloud experience using Microsoft Cloud technologies and talk about what the Microsoft Private Cloud looks like at scale in production, especially as Rackspace tends to implement it. So the objectives that we'll have is we'll review the private cloud ecosystem just to level set everyone. We'll discuss where the private cloud fits in the Microsoft Cloud experience. We'll look at some basic private and hybrid cloud scenarios. And then finally, we'll talk briefly about the future of Microsoft Private Cloud and the integration with Microsoft Azure. What we are not going to do is use a billion slides. There are only 10 slides front to back, including the introduction matter. We probably will not dive into any specific technical aspect of the private cloud technology, so if you came with a question about an esoteric feature of Virtual Machine Manager, we probably won't get to that today. However, I would like to continue the conversation, and we'll have ways for you to be able to get in touch with us, and we'll have information available to you as we go forward, links that may be of value to you, etc. Also, there'll be a follow-up email going out to all the attendees that carries a lot more information, resources, etc. that you can use. But primarily, the last thing we will not do is I will not try to sell you anything except for understanding the Microsoft Cloud experience. So the first thing we want to do is actually take a look at the Microsoft Cloud ecosystem. Cloud really means more than just virtualized resources, but many companies come to cloud first as a means to virtualize and manage their information sources, manage their networking, manage their compute, etc. And we won't talk specifically about things like database as a service or the service bus or websites. Those will all be in what we hope will be future webinars, and there's a ton of information out on the web about those already. But what we will do is we will cover some very specifics around the compute, network, and storage pieces of Microsoft Private Cloud. This is a diagram that is fairly common when talking about Microsoft Private Cloud. It's basically the layer cake that shows all of the things that go into it. And so we'll be looking at an example environment in our next slide, a couple slides, but I wanted to sort of level set what these layers really are. At the very bottom, we always have hardware. It's very, very difficult to do anything in a virtualized environment without having a physical environment. And so in our example environment that we'll show in a minute, we will have a number of physical servers. We are also going to need storage. We'll need some networking capabilities, depending on how you have this set up, obviously racking and cabling, and all of the standard things that you would think of in a physical environment. The first lesson learned then for us at Rackspace has been that there is really a realistic enterprise class minimum in terms of the hardware that we tend to deploy. We've learned this through a number of trial deployments, a number of customer engagements. And so we tend to look at a minimum on our servers as being dual hex core CPUs and 128 gigs of RAM. And so the RAM implications are obvious. The more RAM that we have in the compute environment, the more virtualized resources we can use. But the CPUs are obviously a big piece of that as well. And I say that right up front because I think that there are a lot of people who come to private cloud thinking that they can set it up on 2 or 3 PCs that they bought at Walmart and sort of stick it in a back room and that it'll run and they'll be able to have a cloud experience that is valuable to them, and nothing could be further from the truth. So I would say not skimping on hardware is a big lesson learned. There are some requirements around networking in order to achieve high availability that we won't discuss here, but be aware that beyond just the hardware piece of the CPUs and the servers and so forth, there are quite a number of requirements for high availability networking. We actually have some white papers and some information we can provide on that if you're interested, and that's also covered in a number of Microsoft's reference architectures as well. Moving up the stack there, the virtualization layer basically handles the compute, network, and storage aspects of what we do. Again, cloud tends to be compute, network, and storage, and we handle that in the Microsoft private cloud environment through a combination of Hyper-V and technology called storage spaces. The idea is for us to be able to carve out storage for users, for machines, for the virtual machines themselves, be able to host the virtual machines, and be able to set up virtualized networking. The move toward the software-defined data center makes this an imperative. Moving further up then, we have obviously a database in place with SQL Server to handle various configuration and operational data about the cloud and other sundry data storage requirements. This is different or in addition to database servers that we might have in place for offering database as a service. This is really more about the management side. If you look at the left side of that same layer, much of what we do in the Microsoft private cloud, in fact, what really defines it is the inclusion and the use of System Center 2012. In our standard configuration. And just to give you a brief rundown of what's in there, if you're not familiar with System Center, there are things like Operations Manager, which allows us to monitor our devices. There's configuration management around application delivery and patching. There's a Virtual Machine Manager that allows us to configure and manage the virtual resources that we have. There's an orchestrator that is part of the entire workflow automation of our cloud. How do we spin up and spin down things on schedule, visual runbook authoring, that sort of thing. There's a capability called Data Protection Manager, which is backing up both our VMs and our applications, and it can actually archive our backups into Azure as well in a hybrid environment. Service Manager gives us a platform for automating IT service management around things like IDLE or Microsoft Operations Framework best practices. There's a thing called the App Controller, which allows you to self-service your VMs across private and public clouds. And finally, a thing called Endpoint Protection, which really is nothing more than anti-malware and security. And I say nothing more not to trivialize it, but just to say that that is a capability that's there, and it's basically now table stakes for anyone putting together a cloud environment. A little bit further up the stack then is the Windows Azure PAC, and I want to be clear that this should not be confused with what Microsoft is now calling the Azure Stack. We'll talk about Azure Stack in a little bit, but the Windows Azure PAC is a free add-on that basically provides an Azure consistent experience, allowing you to manage infrastructure as a service, platform as a service, being able to automate and manage database as a service, service bus, etc. There are two pieces to the Windows Azure PAC. There's the administrative portal that allows you to manage not only the platform but also the capabilities that you provide to users of the platform, the tenants, so to speak. And we'll talk more about this when we look at one of our scenarios around departmental allocation. And then the tenant side is the self-service for the actual users of the system. And running underneath all of this is a thing called the Service Management API. It's a collection of REST APIs that are used by the Windows Azure PAC, but also can be utilized by other systems. So if you want to integrate with existing service catalog management tools or things like Remedy or ServiceNow or that sort of thing, that Service Management API is out there. Again, the lesson to take away from this is that it is a little more complicated than it may first seem to stick this thing into production. There are a number of ways to ease the implementation of this, but the Microsoft Cloud ecosystem is, by nature, somewhat complex because it is doing very complex things. But it is an incredibly rich ecosystem that covers all of the things that you would need in order to implement private cloud either in your premise or hosted somewhere else. So let's take a look at what a typical private cloud architecture might look like, and we'll look at it in two different pieces. The first piece is actually the physical nature of the architecture. This is a fairly standard minimum gold spec kind of environment that we stand up for our customers. There are 5 physical nodes in the system plus shared storage. There are 2 management nodes that are clustered together. There are 3 compute nodes that are clustered together. They are physical machines. As mentioned, again, the minimum standard for these is dual hex cores with a bunch of RAM. 128 gig is usually our minimum. We certainly are working now with environments where we can scale up to dual octa-deca core. So just for the Roman challenge, that is an 18-core processor and potentially over a terabyte of RAM inside the physical frame. Again, these management nodes and compute nodes are clustered together for high availability and failover. The shared storage, we at Rackspace support both JBOD and SAN. We can do either one, and either one will work perfectly fine. There are some advantages to using SAN over JBOD in some environments, but really both are available. There is floating around out on the internet a reference architecture guide from Microsoft called the Private Cloud Fast Track Reference Architecture Guide that contains some information around this. And we also have some white papers and additional material that we can provide that show how we have set this up as well. Taking a look at the next slide then, I want to basically break down and show you what the node architecture actually looks like. And I apologize in advance for the eye chart. The reason that I want to show this is to give you the understanding of how the private cloud looks like in terms of implementation. We basically do everything that we can virtualized, and this is our standard node architecture at Rackspace. And you can, I don't want to read this off to you, you can definitely read down through the the items and see what's there. But where required and where possible, we will cluster these virtualized resources together. So, for example, domain controllers, our SQL servers, the operations manager instances, the virtual machine managers, those are duplicated and clustered to provide us with, again, high availability and failover. Other roles that are less critical are generally single instance and divided up between the management nodes, and we have some specific guidance around how to do that, and we certainly can cluster those when required, but they're generally less critical, and it really isn't a requirement. We have more RAM obviously allocated to some roles, others don't care. You can see here from the listing, one of the reasons that we have such a high RAM requirement in our management nodes is that we do have quite a number of virtualized instances running. Now, I do want to point out that this list is actually our base architecture for private cloud. If we are going to add in the capability of database as a service or service bus or some of those things for our clients, there are additional nodes that would be required to be put into place. But this is the basic sort of, again, gold minimum spec that we would put into place for customers. So let's talk about then what a scenario might look like around using private cloud and some of the lessons learned. So on the next slide, this is a fairly typical departmental allocation around private cloud. You can see here that what we have is the management layer. We have 3 compute nodes, and what we have done is we have divided up departmental resources across these compute nodes, across these capabilities, so that we can provide self-service access through the management layer, through something like the Windows Azure PAC to each of these departments. So if we take a look at this, we have marketing, we have accounting, we have the operations group, etc. Dev and test perhaps have 2 plans. And we have this compute environment on the side over here, this compute 3, that we basically have for future use. We are sitting on some excess capacity. And this is a very common scenario for most of our customers, because they're continually finding that as they add the capability in for their customers to come, and for their customers, their end users, to come and allocate resources, that demand tends to grow fairly quickly. We prime the pump, and all of a sudden, you know, the floodgates burst and everyone wants to be in it. The nice part about this architecture and the way that this is designed is that compute nodes can continue to be added as required for this kind of expansion and acquisition. The other thing that this does is it allows us to meter at what's called the plan level. We're able to show chargeback and show back with some of our tooling and self-service and isolation, so that we can tell exactly how much marketing has used, we can tell exactly how much operations is used, etc. Just as an observation on capability, the management layer can control many compute nodes. I don't know that there is a hard technical limit, but certainly you could control, you know, well over 500 or 600 compute nodes. There is, however, a maximum of 64 nodes per Hyper-V cluster, per compute cluster. So once you reach that point, you're going to have to build another cluster, or you'll build multiple clusters with a smaller number of machines and manage those clusters effectively. They can be managed across geographies. At Rackspace, we are moving toward a shared management layer across our data centers to be managing our compute nodes, and so that is absolutely a possibility. And this is a great option where geography is concerned, and we'll touch on that here in a second. But the takeaway, the lesson learned here is that customers come to us often with a need to be able to allocate and deallocate resources to their end users, to their customers. And so the private cloud architecture from Microsoft gives us a very, very nice way of doing that, being able to create a plan that limits the amount of resources that are available to each of the environments, the resources that are available to a specific department or a set of users. And what we have found is that by planning for that up front and planning that allocation methodology up front, we get far better usage, far better insight. Our customers get far better insight into how those resources are being used. And I want to be clear, I've been working in the IT world for 30 years, over 30 years. And I started my career at IBM where everything was in the glass house, and we rolled a $70 million mainframe in, and we shared those resources across everyone, and the management of the resources was at times a little cumbersome and certainly very complex, and it was difficult to go in and do the sort of analysis and show back that that's just frankly today very commonplace and very much in demand. Where this scenario does well for us then is being able to allocate that in a very controlled and tooled environment where we have reporting, we have monitoring, we have analysis that we can provide back to those departmental and division levels as necessary. And so, again, the lesson learned here is that prior planning and prior understanding of how the allocation may be required is definitely a very important part of the onboarding experience, and we certainly assist our customers with that on a regular basis. So let's think about this example here, this departmental allocation, and think of this as one sort of physical geography. Perhaps your headquarters is located in Philadelphia and you want to host this inside your data center or inside a Rackspace data center that will work for your location. But what happens as you start to expand your geographies or acquire or move sort of around the world? Let's take a look at what that scenario looks like. And the slide itself is not altogether that interesting because it simply shows the environment across various and sundry places. But here is where the advantage comes into play of the way that this sort of resource is managed. You can, and many customers often do, have a common management layer that can manage the compute clustering in the place that it needs to be. There is certainly no technical limitation preventing you from having a private cloud in your headquarters in Philadelphia in the U.S. and a private cloud in Sao Paulo and a private cloud in London, and being able to manage all of those as a simultaneous unit, as a cohesive unit. Also, the location could either be premise-based, meaning that it's on your premise, it's on your site, or it could be in a hosted cloud environment in Rackspace's data centers. And again, not here to do the hard sell, but we have data center coverage across the world, and we host private cloud in each of those and are able to support, monitor, and manage those across the geographic distribution. The lesson learned around this is, again, one of planning. There are a few times in my past where we have failed to take into account legislation, local practices, performance, security, et cetera, in our global distribution. And we have done a poor job, I have done a poor job of planning ahead for this type of environment, because there are obviously things like communications between the locations, management and runbook capabilities that have to be dealt with, et cetera, as we start to expand this footprint. And let's go back and look at the previous slide real quick. although there's not a huge amount of difference in the management process for this departmental allocation, the fact that we are in multiple physical environments does bring up, again, some complexities and some management needs that we have to address in the planning process. One of the things that can be done, obviously, is distributing the management layer as well as the compute layer. That can be done quite simply and allow that management process, or we can replicate the management process. And if we look at that slide that we just had up, the geographic distribution, each one of these could be a self-contained cloud platform in its own right, communicating back and forth, and simply have the management in the local areas. Again, it really depends on business practice, business process, the legislation, local practices, that sorts of things. And I know that many of our customers, and just looking at the list of the attendees for this webcast, there's obviously a fairly wide geographic dispersion of need and of desire, and so this becomes very, very important as we plan for the future. The third scenario to look at is one that I call big data on demand, and it really is a hybrid scenario. And we haven't really talked much about the hybrid environment, and so let's spend a few minutes discussing that. The hybrid story where Microsoft is concerned is really quite a compelling story. The ability for us to have an Azure consistent experience across your premise, across Rackspace's data centers, and on into the Microsoft public cloud, which is Azure. And we do have several customers that are moving in that direction of being able to say, hey, I want to be able to put my applications, my data, my capabilities in the tier that makes sense, whether it is locally in my data center because I have security concerns or I have regulatory requirements around the control of my systems, or putting it in Rackspace's private hosting of the Microsoft Cloud because I want to be able to take advantage of resources that I don't currently have physically in my environment, or moving to Azure where I can spin up and spin down things on demand. So again, this is not specifically a private cloud story, but it is an associated story with private cloud, because the addition of a public or hosted private instance allows you to do some expansion of capability, provides you some elasticity around your resources that may be desirable to you. And let's talk about this specific scenario. The goal here is to really be able to provide big data and analytics on demand. I used to work in an organization that had a big data and analytics system inside their premise. We paid a lot of money for it. We paid a lot of money to run it. We paid a lot of money to keep it up. We paid a lot of money to staff to make sure that it was appropriately upgraded, managed, etc. And we utilized that about 4 times a year for quarterly analytics around some of the things that we did. So for us to have this environment sitting out there as part of our private cloud or part of even our physical hardware was extremely cost intensive and really unnecessary given the availability of something like HD Insights in Azure. So in this particular scenario, data is copied, either copied or moved to Azure storage. HD Insights is spun up as required. Data is processed, results are given, and then the big data analytics piece is spun down. So we're only incurring costs, we're only incurring resources at the point of need rather than constantly keeping them running. This is very common, as I said, in sort of period type seasonal data crunching. We're starting to see more and more in terms of the IoT, Internet of Things scenarios where oil and gas companies or other device-heavy companies are pushing lots and lots and lots of data into storage for the purpose of being able to analyze in the future. And I think as time moves forward, we will see more and more of this. The key, again, is keeping that analytics environment available to you on a spin-up, spin-down basis versus running it all the time. Now, that is not to say that you couldn't virtualize this inside your private cloud. It's certainly possible, and certainly there are companies that do it and run this analytics inside their own cloud environment and spin it up and spin it down as they need it. The question really becomes, where should it live? Where should the availability of the data be? What are the costs? And storage and run costs inside Azure are extraordinarily cheap. So if you get to a place, down the road where you're saying, well, we've really got to do some big data, then this sort of a scenario certainly works. But you could just as easily take that box that has Azure around it, and you could certainly push that back into the private cloud environment. And I want to talk a little bit about the lesson learned or the lessons learned around this sort of scenario. And there are a few. The first is that there is a fairly high demand in terms of communication and in terms of access to having this in the public cloud. So whether you're using site-to-site VPN or you're using something like ExpressRoute, the ability for you to communicate with the cloud for this kind of data movement, et cetera, could be, the overhead could be fairly high. And yet, one of the things that you can do, one of the again, lesson learned is that you can move data en masse through something like an import facility. Azure certainly offers the Azure import capability where you load up your data on physical devices, send those physical devices to the Azure data center, allow that to be loaded in, and then the data performed there. This is great for actually seeding your initial environment. So if you have a ton of data on premise that you've been managing for years and you want to move it into Azure for the purposes of analytics, you can. That's certainly a lesson learned, is that there is overhead required there. The second lesson learned is that along with this comes a demand, and the amount of demand and the degree of demand will depend on your scenario, but there is a demand here for automation, for the ability for us to be able to automate movement, to be able to automate the spin up and spin down. And this is, again, just one scenario. This could easily be web on demand, where you're running an e-commerce site, a very small e-commerce site that for the majority of the year in your premise system it runs just fine. But as you start to approach November and the dreaded Black Friday here in the U.S., you want to be able to spin that up. It's the same concept, the same scenario. So being able to automate that through your normal types of DevOps capabilities or other tooling is very critical. And one of the things to be aware of is that back in the system center that we talked about in the very opening slide, there is this orchestration process that allows for that to occur. That orchestration process, I mentioned, gives you the ability to do workflow automation. It gives you the ability to do authoring of the runbooks for your automation. But a critical piece of that as well is that it gives you the ability to do cross-platform workflow integration, so the ability to automate across the environments that you may have. And I don't want that to be a minor point. I want to make sure that that is a point that we dwell on for a moment and then we think about. Because all through these scenarios, that automation becomes critical. It's not just a lesson learned here, but it's actually something that's applicable to your departmental allocation, to your geographic distribution, et cetera. In fact, anywhere where you are going to want to have consistency, a scheduling capability, those sorts of things, this automation piece will come into play. And so, again, I don't want that to be covered lightly. Now, I realize that looking at our time here, you know, I've sort of breezed through a lot of this data, a lot of this information, and I'm sort of looking at the questions that we're getting in the inbox here. I encourage you to think about some of the things we've talked about and give us an idea about things that you're interested in understanding, and we'll certainly cover off on those here toward the end. But I do want to recap a couple of things. One of the things that I am, that I'll make sure you walk away with is that the private cloud environment is definitely a capability that every company needs to or should examine. There are still many, many organizations that I interact with that are still running racks of physical servers, and every single time they need new capabilities, they have to go and put in another rack. And what we and the ability for a department to be able to allocate that or be able to ask for that or require that sometimes can run into some very, very difficult scenarios. But given the way that the cloud works and the elasticity of the resources that we have, again, the lesson learned here is that the more and more that you can move your physical sort of infrastructure and your physical sorts of machines, et cetera, to the cloud, the better off you're going to be in terms of being able to handle demand, being able to handle capabilities around that. And so I want to make sure that you walk away with that point. The next one, the next point I want you to walk away with is that you don't have to go this alone. I said in the beginning I wasn't going to try to sell you on anything, but I am going to take a minute and let you know that what Rackspace does and has tried to do is come alongside our customers and be there to provide them that planning guidance, that architectural guidance, that migration assistance, so that moving becomes a much easier process. We have the ability to migrate from your premise to ours. We have the ability to migrate from your premise to other things such as the public cloud. And we have the capability and certainly welcome the opportunity to manage and support Microsoft Private Cloud, not only in our data centers, but really anywhere where you might have this installed or put. And then the final point before we sort of start to focus on the questions is that this is a fairly dynamic world that we're in, a fairly dynamic environment. Although the Microsoft cloud ecosystem has stayed fairly static over the last few years, there are constantly changes and upgrades and capabilities. And managing your private cloud on your premise, you can require that you keep up with that, where managing it in a hosted environment, somebody else would take that over. But I want to touch on a little bit about the future of this. Right now, Windows Azure PAC is really intended to provide the capability for you to carve out resources around virtualized machines, storage, databases, service bus, and networking, and be able to create allocations, for, again, different departments, et cetera. Right now, it's not Azure itself. Even though it's called Azure, it is not the full Azure experience. So if you're used to working with Azure, there's quite a bit more capability in the Azure environment in terms of what you can do from a pane of glass than there is in the Windows Azure PAC. And so where Microsoft is headed, and I certainly have the same visibility that most of you have in terms of this, they are headed toward a parity experience with Azure, so that what Azure looks like today will be available to you in your data center. It'll be available to Rackspace and Rackspace's data center, so that the experience is now one of comprehensive cloud capabilities regardless of the data center that you're in. And there are a few questions that I see in the list around the Azure PAC. It is an add-on that sits on top of the Windows Server ecosystem. It is free. It is a relatively simple installation process, and in the follow-up email that we will send out, I have several links in that email that will take you to Virtual Academy courses around the Azure PAC. There is an installation walkthrough. There are a couple of white papers, and there is a user's guide around it. One of the things that we are working on in Rackspace as well is creating an environment where potential customers and existing customers can come and exercise the Windows Azure PAC, see it in action. Microsoft also has a virtual lab around the Windows Azure PAC that's actually very, very nice, and I'll have a link in the follow-up for that as well. You can actually spin up an entire Windows Azure PAC environment and be able to interact with it, be able to operate with it virtualized, so that you can really get your hands on it. The thing I would tell you around this is that there are some companies, when they come to the private cloud, they have been used to dealing with Virtual Machine Manager more so than the Windows Azure PAC, and so their default sort of go-to tooling around the virtualization environment is VMM. We are slowly but surely trying to encourage our customers to move to Windows Azure PAC, especially for providing that controlled experience out to our various and sundry, again, departmental allocations, divisional allocations, teams, etc. So take a look at those materials that that come out in these follow-up emails, and avail yourself of those resources. And so what I want to do now is sort of take a look at some of the other questions that are coming in. And so, Tracy, if you're on the line, I believe you're going to moderate through some of those questions.
Sure. Happy to do so. Thank you for all that information you provided. It was great. Let's see. Someone wants more information about Azure PAC, and are Azure PAC and other tools available on the Rackspace Marketplace?
I am not aware that they are. Typically, we provide those as part of a private cloud implementation. They are not available today in our public cloud. That's not to say that that might not be something we do in the future, but it is right now isolated to our private cloud installations. And I hope that answers the question that came in.
Yeah, they could always follow up if it didn't, with another question.
Absolutely. And like I said, I want to make sure, I want to hit on that for a second. I do really encourage the viewers of this webinar to reach out to us. Again, we can certainly put you in touch with the right people to answer your questions, questions that remain unanswered or questions that you come up with later. And we're pretty good. The group that I work in, which is product and engineering, we're pretty good about not being the hard sell guys. And so once we, figure out what you need, we definitely want to get you information so that you have everything you need to make a decision about where to put this, how to put it, etc.
Great. Okay. Thank you so much. Here we go. What are the considerations of a hybrid deployment to meet healthcare privacy requirements? Should I consider keeping sensitive data in my data center and move business transaction transactions to the Rackspace Cloud?
Boy, that's a great question. So it hits on a number of issues, privacy of data, it hits on security, all of that. So let's talk through, and I'm not an expert on HIPAA or any of the other sorts of compliance things that are out there, but I have dealt with a number of scenarios like this, not only in healthcare, but in insurance or anywhere where you have privacy concerns around personally identifiable information. It's certainly one approach is to keep all the sensitive data in your premise data center and as asked, move those business transactions to the Rackspace Cloud. Certainly where it is possible to anonymize data, the public cloud is even an option for doing analytics or doing transactional batch type or batch type processing. But I think that there is a couple of things that need to be discussed. One is that the environments that we create in the Rackspace private cloud, in our hosted private cloud, our environments are rigorously secured. We pride ourselves in having extremely secure and monitored environments, and so really I would actually say that you would probably have the same experience and be able to have the same sort of privacy isolation in our data center as you would have in your premise. And in fact, I would argue that in some cases, and I'm certainly not the spokesperson for this or anointing this, but in some cases, even moving to the public environment and having a premise, a private, hosted, and public footprint for that is even an option. It's been a few years now that the Dutch have actually allowed much of their national health information, their healthcare information, to be managed in the public cloud environment. And more every day we are seeing new security capabilities, new privacy capabilities that allow the public cloud to be just as secure. But certainly for this specific question, that is one possibility. I think another consideration around the hybrid deployment is really one of perhaps size of data, perhaps long-term storage of data, how long are you required to keep that information around. Every compliance law that's coming out nowadays seems to have an additional need around the longevity of the data, how long it gets stored. And that is, again, certainly an area where you can use the Rackspace Cloud for that, but also you could potentially push encrypted long-term data into the public cloud and store it there for pennies on the dollar and being able to move that. So I guess to cap that question off, there are a number of considerations to look at. Hopefully I've covered a few of them and certainly would welcome additional questions even after the webinar.
Great. Thank you so much for that answer. And as Kent said, feel free to submit your questions. We do have a little bit more time, and we're happy to send them over to Kent to answer. Here we go. As a data scientist, applications developer, and statistician, I mainly use VBA to write laboratory applications. How best can I try the capabilities of Azure?
That's a good question. Even though this is not necessarily a webinar about Azure, it's certainly something that we get asked a lot. There are a couple of different approaches. If you're an individual and you're attempting to try that out, Microsoft certainly offers the trial subscription capability, and so you can easily sign up for that. If you are a Microsoft an MSDN member, your MSDN membership benefits will come along with some capability of accessing Azure. But I do think it's important to point this out. I'm a big believer in hands-on. I'm a big believer in sort of driving the car around before I actually bite off on it. And I think that Microsoft has done a great job of doing that, not only with Azure, but also, again, with the private cloud side through their virtual labs and through some of the walkthroughs that they have. So I would encourage you to, I'd encourage the asker that question to reach out, get a trial subscription, play around with it. Certainly the ability to spin things up and spin things down is relatively inexpensive. I have a subscription myself that I use for testing certain things. I do a lot of stuff every month in it, and the cost to me is negligible, under $100 usually every month, and I usually have stuff running a lot. So hopefully that answers that question.
Sounds good. Here's another question. With respect to application availability, is it possible to fail over to a remote instance? For example, can my database fail over from one data center to another?
Yeah, absolutely. One of the scenarios that we see quite a bit is this high availability and disaster recovery scenario for something like SQL Server. And so we certainly have the ability to set up environments in multiple places, failing over from your premise, for example, your premise data center into Rackspace's data center, or failing over from Rackspace's data center on the private cloud into Azure in the public space. So those scenarios are absolutely doable. We actually have a webinar that I believe we've done just in the recent past talking about what that might look like, and I'll make sure that the link to that or that information about that gets out in the follow-up, because it is a very, very common scenario. And in fact, from a private cloud perspective, we really don't see that many customers coming to us where some public failover aspect or some additional Rackspace data center failover would be valuable. Almost every scenario has that requirement in it.
Great. There's another question for you, and it's, I understand that Microsoft will soon end support for SQL 2005. My SQL application is quite old, but I'd like to move it to RAM processing. What level of development modifications are likely required?
Boy, that's an open-ended question for sure. Without knowing the specifics about the application, it's practically impossible to analyze that. I will say this. That much of the data capabilities that are in both private cloud with SQL Server or in Azure with the Azure Platform as a Service database capabilities are very, very comprehensive and very, very similar to what's in your existing, so that if you have been writing your applications in .NET, for example, and using the standard data access capabilities in .NET, the number of modifications that you might require to move into that environment should be fairly minimal. However, again, it really sort of depends on your need, and it sort of depends on what your application environment looks like today. And I will take a minute to sort of expand on this question, because I think it's important. Often customers come to the cloud, companies come to the cloud assuming that what they can do is bring all of their existing baggage, their existing warts, their existing systems, and sort of dump it in the cloud and expect it to be this nirvana-like environment where all of a sudden things cost less and things perform better, and et cetera, et cetera. And that's usually not the case. Usually what happens is customers, companies in general find that moving to the cloud can be a fairly arduous experience. It can be complicated depending on how your applications are designed, how your databases are structured, how your data storage works, how your networking is designed. And so one of the things that I always tell prospective customers that are moving to the cloud is to really sit down and plan through what applications make sense to move and in what order, because sometimes the journey to the cloud is about sequencing. It's about identifying those applications that seem to be fairly well done in terms of best practices, fairly well done in terms of application structure. It could be that you are a company that has bitten off heavily into the DevOps environment, doing continuous integration, continuous delivery, those sorts of things. And if you're already doing that in your own systems, then chances are your ability to move to the cloud will be much better. Your journey will certainly be more comprehensive and certainly more rich in terms of what you're able to wring out of the cloud, as opposed to simply virtualizing physical servers if they aren't already virtualized, or picking up VMs and simply jamming them into another private cloud. Now, having said that, there are certainly advantages to that. There are certainly advantages to moving things out of your data center and moving them into the cloud environment in terms of removing the physical overhead in your building, power cooling, maybe even up to and including certain staff positions or contract positions that you have to continue to manage this. But I will say that a simple question like what kind of application modifications might I have to do is a great jumping off point to talking about the broader transformation experience of moving to cloud. And again, not trying to sell anyone on anything, just making the observation that Rackspace does quite a bit of transformational consulting. We certainly want to be part of that journey with our customers, and so I encourage anyone that's sort of got that scenario to reach out to us directly. The slide that just went up is sort of interesting, and I do want to get back to questions because we have a few more minutes. But the slide is interesting because this is sort of the statement I've been making for a while now here at Rackspace. We really do want to be known for doing Microsoft Cloud technology, coupling that with our long-term Rackspace expertise. We have a very long relationship with Microsoft. We're a 5-time gold hosting partner for them and partner of the year for them. And we really want to, though, be able to do that across any data center. And that does come as a shock to people sometimes when they hear that. We really do want to cover wherever you want your cloud to be from a Microsoft perspective. And so, Tracy, I guess it looks like we have time for one more question.
Okay, here it is. There are a lot of repetitive tasks our admins do, like managing load balancing. Can they be automated?
Absolutely. They can be automated, and let's talk about what automation really means at a couple of different levels. Automation in sort of the general sense is the ability to have a consistent script-like approach, if you will, where certain steps and certain sequences of steps are done in the same fashion all the time, every time, exactly the same way. Microsoft has a few technologies that support this. The primary technology that people will be familiar with is the scripting language and the scripting capability of PowerShell. It's almost impossible to take a look at the Microsoft Cloud world anymore without seeing PowerShell used as a tool that allows you to automate, very common tasks. But that automation then can be sort of an on-demand thing. You actually have an admin that sort of keeps a script library and can go execute the script as they need to. That automation can be done in response to an event. So something happens in your system and all of a sudden you need to go do something like automating load balancing or adding disk space or whatever it happens to be. That can be a response, a reactive sort of a thing. It can also be done proactively based on a schedule. So I had talked earlier about, demand. If you know that, on Thursdays and Fridays every week your system has a lot of demand around the web heads, the web side of what you do, you certainly can automate the spinning up of additional web servers, the spinning up of additional application servers. So absolutely it can be automated. And I want to stress that automation really is a fundamental underpinning to your success in the cloud environment. And so if you're not already looking at automation and you're not already involved in that, I certainly would encourage you to reach out and look at it. There are a couple of links in the follow-up email that we'll send out that talk about the orchestration capabilities in the private cloud and how those can be used to execute this automation. So really dig into that, and I think you'll be pleasantly surprised at the amount of work that a person is doing today that certainly could be done in a consistent manner by automation in the future.
Okay, that's great. Thank you so much, Kent. You did such a great job, and it was a pleasure hosting you. And I appreciate it, and I'm sure the audience also appreciates you taking time to be with us. I'd like to remind the audience that you'll be getting a follow-up email with a list of the URLs that Kent talked about during the presentation, so look for that. That should probably come out tomorrow. So with that, I'd like to thank the audience for joining us today. This event was sponsored by Rackspace and presented by Virtualization Review. Thanks again, everybody, and enjoy the rest of your day.
This concludes today's conference. You may now disconnect.